Uh, Good evening, guys, and welcome to interview preparation session which is conducted by 360 DGTMG. Uh, in this session, we'll just cover some of the topics regarding data science, some of the questions regarding data science. Uh, for the day, let's start with the first question, and the first question is explain the steps in making a decision tree. So these are all some of the topics have been covered regarding the data science. So decision tree is one of the topic in it. So if anyone knows the answer regarding this decision tree, what are the steps behind decision tree and all, can ping their answers or views in the chat box. We'll discuss the answer within a minute. Okay. Okay, guys. Now, as we look into this, explain the steps in making a decision tree. So, every process should contain some steps and some procedure to go on, and we should follow them. And to make a decision tree, these were the steps to be followed. And the first step is we have to take the entire data set as an input. So, for doing such cases, we will have some input required data sets, right? So, we have to take the entire data set as a single input. Then we have to calculate the entropy of the target variables as well as the predicted attributes. Okay, what are predicted attributes? So, in the data sets which have been gone through, so in some cases, in some mild cases, there are some null values. Okay, so to fill those null values, empty rows or columns to fill those them. So we have to predict some data. So we have to calculate the entropy for all the variables as well as the predicted attributes also. As we jump, as next step, we have to calculate your information gain of an attribute. So what's that? Uh, we gain information on sorting different objects from each other. So we'll just gain by sorting with different objects. And the next step is we have to choose the attribute with the highest information gain as a root node. The attribute which we have been chosen should be of highest information gain as compared to with a root node, and repeat the same procedure over every branch until the decision node of each branch is finalized. So yeah, these were the 5 steps to be followed to go through this decision tree. The first step is we have to take the entire data set as an input. You have to calculate the entropy for the normal variables as well as the predicted attributes. You have to calculate the information gain. You have to choose the attribute with highest information gain of root nodes. You have to repeat the above 4 steps until the decision node of each branch is finalized. Okay, guys. As we jump into the next question, how can you avoid overfitting your model? So yeah, this is the second question, guys. If anyone knows the answer, please ping in the chat box and we'll discuss the answer in a minute. And now, as we look into this, how can you avoid the overfitting model? So, overfitting. Overfitting, it basically refers to a model that is only set for a very small amount of data and ignores the bigger picture. There are three main methods to avoid this overfitting. Overfitting, which actually suppose you have been going there are different amount of data sets where we can where the data set requires a small, consider attaches with some smaller data other the data set which has some bigger data picture. So this if in case of this bigger picture data sets, then there are three methods to avoid this overfitting. So the first method is keeping the model simple, which means we used to have to take very few variables into consideration into the account. They were removing some of the noise and the training data. This is the first step. We have to keep the model as simple as possible. Use cross-validation techniques such as k-fold cross-validation. Use regularization techniques such as lasso, penalize certain model parameters if they're like to cause overfitting. Okay. So by using these steps, this overfitting can be reduced. So as we jump into the next question, what are dimensionality reductions and its benefits? So if anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yes. Now, as we look into this, what are dimensionality reductions and its benefits? So, this dimensionality reduction, it basically refers to the process of converting a data set with vast, with huge amount of very vast amount of dimensions into data with fewer dimensions to convey similar information concisely. Which means the data which have very vast amount of dimensions, the data which have very short amount of dimensions to convey the similar information without any reduction of data. This reduction helps in compressing data and reducing the storage space. So by using this dimension reduction, it compresses the data as well as it improves the storage spaces. It also reduces the time as fewer dimensions less to lead to less complexity. It removes the redundant features. For example, if there are no points in storing a value in two different units, meters and inches, so it reduces this all functions. Okay. So as we jump into the next question, how should you maintain a deployed model? How can it be maintained? If anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this, how should you maintain a deployed model? Those are some steps to be maintained for a deployed model. Those are monitor. So, what is constant monitoring of all models is needed to determine their performance and accuracy. Okay, for these are very to constantly monitoring all kind of models. It should be some performance, right? For accurate, it should be somewhat accurate. When you change something, you want to figure out how your changes are going to affect things. So suppose you have been changing the code, so in Python or R program. Suppose you have been changed the code, right? So now what were the changes will run at the output side. From the output side, you are going to affect how they are going to affect these things. So this needs to be monitored to ensure it's doing what it's supposed to do. Okay, this is about the monitoring and evaluate. Evaluation metrics of the current model are calculated to determine if a new algorithm is needed. Suppose you have been going across a data set. Suppose for the current data model, if there are any alternate or any higher algorithms are needed, it basically it evaluates any higher algorithms if needed. So compares. The new models are compared to each other to determine which model performs the best. Rebuild. The best performance model is rebuilt on the current state of data. It totally depends on the current state of data. How can you select K for K means? This is another model in the data science. So if anyone knows the answer regarding this K and K means, can ping me in the chat box and we'll discuss the answer within a minute. Yes. Now we look into this. How can you select the K for K means? So it also has some procedure. So first of all, we use this elbow method to select K for K. What is elbow method? It is a type of method, and we use it for selecting K means K for K. The idea of the elbow method is to run K means clustering on the data set where K is the number of clusters. Okay, it runs in a particular way where K is should be in the number of clusters, and within the sum of squares, it is defined as the sum of the square distance between each member, which means the distance between the two different members inside a cluster, and its centroid. This is how we select K for K means by using this elbow method. As we jump into the next question, how can outliers values be treated? So, if anyone knows the answer, please ping me in the chat box, and we'll discuss the answer within a minute. Yeah. And now as we look into this, how can outlier values be picked? So you can drop outliers only if it is a garbage value which is not useful for the required data. For example, you have been gone across a height of method which is of ABCD field. This cannot be true as the height cannot be string value, right? So if in case outlier can be removed, the outlier have extreme values, then it can be removed. For example, if all the data points are clustered between 0 to 10, point lies at 100, then you can remove this point. So this is how the outlier values can be removed. So if you cannot drop outliers, you can try the following methods. Try a different model. Data detects as outlier by linear models, right? It can be fitted by non-linear models. Therefore, be sure you are choosing the correct model. Try normalizing the data. After uploading the dataset, try to normalize the data. If in case this way the extreme data points are null to a singular, you can use algorithms that are less affected by outliers. An example would be a random forest. As we jump into the next question, uh, this is one of the interview question have been asked. Okay, so you are given a data set on cancer detection. So you have built a classification model and achieved an accuracy of 96%. Why shouldn't you be happy with your model performance? What can you do about it? So this is a question which is being asked by a recruiter in some of the interviews. So yeah, please try to attempt this question in the chat box. If anyone knows the answer, please bring them in the chat box and we'll discuss the answer. So yeah, as we look into this question, yeah, cancer detection, it basically results in some balanced data. As an imbalanced data set, the accuracy should be based on a measure of performance. It should be important to focus on the remaining 4%, okay, which results in the patients who were wrongly diagnosed. Early diagnosis is crucial when it comes to the cancer detection and can greatly improve a patient prognosis. So, hence, to evaluate model performance, we should use sensitivity, true positive rate, specificity of this true negative rate. So F measures the determination the class-wise performance of the classifier. So as we jump to the next question, we want to predict the probability of death from heart diseases based on the three factors: age, gender, and blood cholesterol. What is the most appropriate algorithm for this case? So this is the MCQ question, guys. So I'll be giving you some options, and those are option A, logistic regression; B, linear regression; C, k-means clustering; and appropriate algorithm. So I just try to find this. Okay. Yes. Yeah. Now I think you can see the entire question here. Just yeah, this is the question, guys. So by which model, which algorithm we can choose this case? Okay. If anyone knows the answer, please ping me in the chat box. Come on, guys. This MCQ question, right? You can go across. Yeah. Now, as we look into this, these kind of cases and algorithms can be done by using this algorithmic logistic regressions. So, in the chat box, Sahina and Hemanita have been correct, wrote the correct answers. And as we jump into the next question, after studying the behavior of population, you have to identify four specific individual types and that are valuable to your study. So, if in case you would like to find all users who are most similar to each individual type, which algorithm would be most appropriate for this kind of studies? And the options are k-means clustering, linear regression, association rules, and decision. Yeah, I think you people can see the whole question with options, right? So try to attempt this, and we'll discuss the answer within a minute. Yeah. Now, as we look into this k-means cluster, as we are looking for the grouping people together, specifying by four different similarities, it indicates a value of k, right? So therefore, k-means clustering option A is a most appropriate algorithm for this kind of studies. And Karun Singh, you have been said the right answer. Chat box and good and Hemalath. Okay. As we jump into the next question, what are the feature vectors? So if anyone knows the answer, try to put them in the chat box and we'll discuss the answer with them. Yeah, as we look into this, what are feature vectors? A feature vector is an n-dimensional vector of numerical features. That basically represents an object. In machine learning, feature vectors are used to represent numeric or symbolic characteristics of an object in a mathematical way that's easy to analyze. Okay, by using these feature vectors, we can represent some of the numeric as well as some symbolic characteristics of an object, which is very easy to analyze. Okay, uh, right. Yeah, yeah, Sahil, this is how this feature vector should be work, and this is how it works. So, okay, as we jump into the next question, what is logistic regression? If anyone knows the answer, please ping me in the chat box, and we'll discuss the answer. Yeah, now as we look into this, what is this logistic regression? Yeah, logistic regression is also known as a logic model. It is basically it's a technique used to forecast the binary outcomes for a linear combination of predicted variables. Okay, this is how logistic regression works on. And as we jump to the next question, what are recommended systems? I'll be just giving you a minute. If anyone knows the answer, please put it in the chat box and we'll discuss the answer shortly. Yeah. Now, as we look into this, what are the recommender systems? Recommender systems are a subclass of information filter systems, which are meant to predict the preferences or ratings which are used would give to a product. Okay, this is how the recommender systems are used in the sciences, along with the modules and procedures followed. And explain as we jump into the next question. Explain cross validation. If anyone knows the answer, please ping in the chat box, and we'll discuss it in a minute. Yeah. As we look into this, explain cross validation. Cross validation is nothing but it is a modal validation technique which is used for evaluation how the outcomes of a statistical analysis will generalize to an independent data set. Okay, and it is mainly used to backgrounds, whereas the object is to forecast and one wants to estimate how accurate a model will accomplish practice. It basically wants to forecast how accurate that is how this cross validation function goes on. As we jump into the next question, what is collaborative filtering? If anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yeah, Sahina. This is how according to the considerations we have been gone across, it basically totally depends upon such kind of instructions to be go on. Yeah, as we look into this, what is collaborative filtering? The most recommended system is to filter process to find the patterns and information, which means how by collaborating some numerous data sources, perspectives, and several agents. That is how this collaborative filtering works. As we jump into the next question, what are the drawbacks of the linear model? So, if anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this, what are the major drawbacks of linear model? These were the some of the drawbacks of the linear models, and those are the assumptions of linearity of the errors, and it can't be used for count outcomes or binary outcomes, and these are overfitting problems that can't be solved. So these were the some of the drawbacks for this linear model. As we jump into the next question, how regularly must an algorithm be updated? Like, if anyone knows the answer regarding this, please ping me in the chat box and we'll discuss the answer within a minute. Yeah, as we look into this, uh, you will want to upgrade an algorithm when regarding some cases, right? So, and those are, you want the model to evaluate as data streams through infrastructures. The underlying data sources should be changes, and there is a case of non-saturated. So, in such cases, you have to regularly alter the algorithm, update the algorithm. Okay. Why is resampling done? Why does the process? Why should we use that process? If anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this, why is resampling done? Resampling is done in any of these cases. These were the three cases where should we use this resampling techniques by estimating the accuracy of sample statistics by using subsets of this accessibility data or drawing randomly with replacement from set of data points, and also by substituting labels on data points when performing significant tests on it, and also by validating the models by using random subsets like bootstrapping, cross validation. By using this, if this case is alerts, then we can use this resampling techniques. Okay, so as we jump into the next question, what is in selection bias? If anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this, selection bias, it is a problematic situation in which error is introduced due to some non-random population sample. This occurs due to some non-random population samples. Okay. Uh, this is where the selection bias is a problematic situation. Okay. What As we jump into the next question, what are types of biases that can occur during sampling? So while using some these sampling techniques, there are some biases which may occur, right? What are those biases? If anyone knows the answer, please ping me in the chat box and we'll discuss the answer within a minute. These were the types of biases that occurs during sampling: selection bias, undercoverage bias, and survivorship bias. These were the three biases which occurs during the sampling. So as we jump into the next question, what is survivorship bias? If anyone knows the answer, please ping in the chat box and we'll discuss the answer within a minute. Yeah. Now, as we look into this survivorship bias, it is a logical error or focusing on aspects that support some surviving a process and casually overlooking those which are not because of this lack or prominence. And this can lead to wrong conclusions in numerous cases. So this is how this survivorship bias works on. So that's for the day, guys. Hope this session might helpful for you in your further interview rounds and all. Uh, so let's meet tomorrow, guys. Thank you. Bye. Have a great day.